The 12 factor methodology is basically a set of best practices for building software as a service applications. The methodology was first described by Adam Wiggins in 2011, and it is based on the experience of building and deploying web application at Heroku, a platform as a service provider. We can say that it's a series of rules and guidance for helping developers to build cloud ready PaaS applications, PaaS or SaaS, both kind of applications. So, what are the important factors related to this 12 factor app methodology? So, these 12 factors are code base, dependency, config, backing services, build, release, run, processes, port binding, concurrency, disposability, dev production parity, logs, and admin processes. Let's look briefly at each of the factors now and see how they map to continuous delivery practices for Java applications. So the first factor is code base, and it says that one code base tracked in release and control, many deploys. So the idea is that there should be exactly one code base for a deployed service, with a code base being used for many deployments. And if we talk in the context of Java, then we can say each Java application should be tracked in a single shared code repository. Deployment configuration files like scripts, Docker files, and Jenkins files should be stored alongside the application code. The second is dependencies, and it says that explicitly declare and isolate dependency. That is, all dependencies should be declared with no implicit reliance on system tools or libraries. Dependencies are commonly managed within Java application by using the build tooling like Maven or Gradle, and OS level dependencies should be clearly specified in the associated virtual machine image manifest, Docker file, or serverless configuration files. Then we have config, store config in the environment. So it says that configuration that varies between deployments should be stored in the environment variables. The 12 factor app guideline suggests that configuration data should be injected into an application via the environment variables. So, in practice, many Java developers prefer to use configuration files to manage these variables, and there can be potential security issues with that, particularly when building virtual machines or containers that contain the secret codes. The next factor is backing services, and it says that treat backing services as attached resources. So backing service basically is any service that app consume over the network as part of its normal operation, like your MySQL, CouchDB, and your messaging queuing system like RabbitMQ and all, and SMTP services. So any service that your app consume over the network as a part of its operation. So this factor says that all backing services are treated as attached resources and attached and detached by the execution environment. The next point is build, release, run. Here it has been suggested that strictly separate build and run stages. The delivery pipeline should strictly consist of build, release, and run. Then we have the processes. Execute the app as one or more stateless processes. And the idea is that application should be deployed as one or more stateless processes with persistence data stored on a backing service. Building and running a Java application as a series of microservices can be made easier by using the virtual machine images, container images, or even the serverless function as we know. Next, we have port binding, that is, export services via port binding. So basically, the self-contained services should be make themselves available to other services by specified ports, and we are used to of exposing application services via ports, like running application on Jetty or Apache Tomcat. Then we have concurrency, which says scale out via the process model. So here concurrency is advocated by scaling individual processes. Next we have disposability. Maximize robustness with fast startup and graceful shutdown. So here fast startup and shutdown are advocated for a more robust and resilient system. The next factor is dev prod parity. That says keep development, staging, and production as similar as possible. So basically, it says that all environments should be as similar as possible. And as we know that the use of VM or container technology in combination with orchestration technologies like VMware, Kubernetes, and Mesos can make this easier in comparison with traditional bare metal deployments, in which the underlying hardware and OS configuration is often significantly different from that of developer or test machines. Then we have logs that says treat logs as event streams. So application should produce logs as event streams and leave the execution environment to aggregate. And Java, as we know, has had a long relationship with the logging frameworks, and even more modern frameworks like Logback and Log4j2 can be configured to stream to standard output or stream to disk. Then we have admin processes, the final factor in this 12 factor app methodology, and that says run admin management tasks as one of processes. Any needed admin tasks should be kept in source control and packaged with the application. That's the whole idea behind this. So, the 12 factor app methodology provides a set of guidelines for building modern, scalable, and maintainable applications that can be easily deployed and run in different environments. It is designed to be used in conjunction with other best practices and methodology like Agile and DevOps to help the companies deliver software more quickly and efficiently. And if you need more information regarding this methodology, then you can visit the 12factor.net website, which I have mentioned as a source of this entire idea.